For more than 40 years, there's been one king of the battlefield, and that's the M1 Abrams tank. Now we all know it's a beast of steel and firepower, right? But its real secrets, the things that make it so insane, aren't just its gun or its armor. No, they're in the engineering. Some really wild, almost backward choices that make it totally unique. So let's get into it. Let's pull back the armor and really see what makes this thing tick.
Okay, if you've ever been lucky enough to hear an Abrams startup, you know exactly what this quote is talking about. It's not that low, guttural rumble of a typical tank diesel engine. No way. It's this high-pitched scream, almost like a jet. And that one sound, that single iconic noise, it really gets to the heart of the mystery of the M1, doesn't it? Why on earth would you power a 60-ton behemoth with an engine that feels like it belongs in the sky?
All right, so to figure that all out, here's our game plan. We're going to break this thing down piece by piece. First, we'll touch on its legendary history. Then, we dive right into the heart of the machine, that crazy turbine engine. After that, we'll look at the science behind its armor, how it protects its crew, how it manages all that weight, and finally, we'll see how this absolute titan has changed over the years. So let's kick things off with a little history lesson. The M1 officially joined the party back in 1980, but it really made a name for itself during Operation Desert Storm. I mean, picture it. These tanks just racing across the desert, completely outclassing the Iraqi armor. And here's the crazy part. Now, over 40 years later, that same basic platform is being sent to the front lines in Ukraine. That just tells you everything you need to know about how forward-thinking and adaptable this design really is. Okay, now for the main event. Let's get right to the heart of the M1, the feature that everyone talks about and argues about. We're talking, of course, about its Honeywell AGT 1500 gas turbine engine. Seriously, putting an engine that was basically designed for fast, light aircraft into a super heavy battle tank. I mean, it just sounds completely backward, right? So what in the world were the engineers thinking?
Well, the whole decision really boiled down to one huge engineering puzzle they had to solve. How do you cram an absolutely insane amount of armor onto a tank without making it a slow, clumsy, easy target? The answer, as it turns out, was to think about power and weight in a totally different, kind of radical way.
And look, the raw numbers right here tell an amazing story. Check this out. The M1's turbine engine is pumping out 1,500 horsepower, and the engine itself only weighs about 1.1 tons. Now compare that to the Challenger 2's diesel engine, which is a great engine, by the way. It's got less power, at 1,200 horsepower, but it weighs almost double. That incredible power-to-weight ratio, that is the Abrams' secret weapon. And to really wrap your head around just how heavy this thing is, think about this. A fully loaded Abrams weighs the same as 56 Toyota Corollas. It's an absolute monster. And yet, because of that turbine engine, it can go from a dead stop to 32 kilometers per hour in just 7 seconds. That's just terrifying agility for something that massive. Truly. But wait, it gets even better. The advantages don't just stop with raw power. This turbine engine has a huge logistical trick up its sleeve. You can pour almost anything into it, and it'll run. Diesel, gasoline, kerosene, marine diesel, you name it. Now, just imagine you're in a war zone where getting the right fuel is a nightmare. This flexibility is a total game changer. It makes working with NATO allies so much easier, and it means the tank doesn't care if it's in the blistering desert heat or the freezing cold of Ukrainian winter. So, what do you do with all that extra power from that lightweight engine? Well, you use it to carry an unbelievable amount of armor. Now, the exact recipe for this armor is, one of the most closely guarded secrets on the planet. But we do know the basics. It's built around a revolutionary composite material, and we can dig into the science of what makes it so darn effective. Okay, so the first piece of the puzzle is something called hardness. It's pretty simple, really. Just think of a diamond. It's so hard it can scratch pretty much anything else without getting scratched itself. In armor, this is your first line of defense. It's designed to shatter or blunt an incoming projectile. But hardness alone isn't enough. You also need toughness. Now, toughness is a material's ability to take a massive hit, to absorb all that energy without just fracturing into a million pieces. Think of it as the opposite of being brittle. Like a ceramic dinner plate. It's pretty hard, sure, but it has zero toughness. Drop it and it's gone. For great armor, you absolutely need both. And this is where ceramics just blow everything else out of the water. Just look at this. Your standard armor steel, it has a hardness rating of around 380, but silicon carbide, which is a type of ceramic they use, clocks in at 2,500. That is, over 5 times harder?
And it's lighter, too. It's pretty much the perfect material for just obliterating a projectile on impact.
So, how does this actually work? It's genius, really. The armor isn't just one big slab of ceramic, it's a whole system. It's designed to stop things like a long rod penetrator, which is basically a super fast, super dense metal dart. So here's what happens. When that dart hits the outer steel plate, the shockwave instantly pulverizes the ceramic layer inside. And what you get is this dense cloud of incredibly hard, abrasive particles that just grinds the incoming round into dust as it tries to force its way through. It literally eats the projectile.
And you know, this obsession with survival, it goes way beyond just the armor. The entire philosophy of the M1 isn't just about destroying the enemy, it's about making sure the crew inside gets home safe. And you can really see this in some very deliberate and honestly pretty surprising choices they made with its firepower and crew layout.
All right, here's a fact that might actually shock you. Unlike a lot of other modern tanks, especially Russian ones that have these complex automatic loaders, the M1 Abrams has a person, a fourth crew member whose job it is to load the main gun. I know, right? At first glance, that sounds incredibly old-fashioned.
So the big question is that a weakness? Is it a disadvantage? Well, the US military would tell you absolutely not. In fact, they argue it's one of the tank's biggest strengths. See, the choice to stick with a human wasn't about being cheap or behind the times. It was a very deliberate, strategic choice that's all about reliability and versatility.
I mean, just think about it. An autoloader is just one more complicated piece of machinery that can and will break down in the middle of a fight. A human? Way more reliable. But it's so much more than that. That fourth person can help fix the tank, they can stand watch, they can provide security when you're stopped. And if, God forbid, someone else gets hurt, they can step in and take over their job. It's a level of adaptability and redundancy that no machine can ever match.
And that same keep the crew alive thinking is crystal clear in how the Abrams stores its ammo. See, in most tanks, if your ammunition gets hit, it's game over, catastrophic. But in the Abrams, all the ammo is stored in a separate armored box at the back of the turret. A heavy blast door separates it from the crew, so if the ammo does get hit, that door contains the blast, and special panels on the roof are designed to blow up and out, sending that massive explosion safely away from everyone inside. It's an incredible piece of life-saving engineering.
Okay, so we've established we have this super heavy tank that's also super fast. So how on earth do you control that much mass when it's barreling over rough terrain? The answer is in a system that's often overlooked, a real unsung hero, the suspension. And the improvement over the tank it replaced, the M60, is just staggering. The old M60's wheels could move up and down about 20 centimeters. The M1 Abrams, with its advanced torsion bar suspension, which is basically a super strong spring that twists, has almost double that at 38 centimeters. This is why it can practically glide over rough ground at speeds that would have literally shaken older tanks to pieces.
But this system has this really fascinating little design quirk. So the torsion bars themselves are these long steel rods that run all the way across the bottom of the tank. And to get them all to fit, they have to be staggered. So if you look closely, you'll see the wheels on the left side of the tank don't line up perfectly with the wheels on the right. It's a really clever engineering compromise that lets them squeeze every last millimeter of performance out of the suspension.
And that brings us to the final and maybe most important piece of the M1 puzzle. You have to understand, the Abrams isn't some 40-year-old relic. It's a 40-year-old platform that has never, ever stopped evolving. The original design was just so good, so forward-thinking, that it's been the perfect base for decades of upgrades. And you can see that evolution so clearly when you look at its history. I mean, it started out with a 105mm gun. Then, in the 80s, it got the bigger, badder 120mm smoothbore cannon. Then in the 90s, the M1A2 gave the commander his own thermal viewer, which was a huge deal. And more recently, the SEP upgrades have brought it fully into the digital age, with things like remote weapon stations and battlefield networking. It's this constant cycle of improvement that keeps it on top.
So, in the end, the M1 Abrams is just a masterclass in engineering trade-offs, isn't it? It gives up fuel efficiency to get insane power. It chooses a human crew member over complex automation for the sake of reliability. It's all a brilliant series of compromises, all for one goal: to dominate the battlefield. But as warfare keeps changing, with drones and smarter weapons becoming more common, you have to wonder, what's the next great compromise going to be? What will define the tank of the future?